I was probably an odd little kid. I had this pair of overalls, and I loved these overalls because when I would put them on, it meant that it was time to go out to the garden with my mom and my sister. And I would go out and I would dig and plant seeds and water the seeds and watch the plants grow. It was this magical process, this mysterious thing that turned a seed in the earth into something that I could eat. When I would get tired of digging and watering, my sister and I, we would sit down between the rows of beds and we would bask in the sun and look down beneath us. Look at the ground, which maybe to us as adults seems like something that's just bland, stagnant. But to my child's eyes, I was able to be fascinated by this world beneath my feet. I found all sorts of things. I found spiky caterpillars that I knew better than to touch, earthworms. And this sense of wonder has grown into a real gratitude for the fact that I live in this place. I remember being able to just go and graze through the garden with my sister, like miniature little cattle feasting on snap peas and cherry tomatoes. That sense of wonder and mystery with the land beneath my feet. I grew up with that, and I had that well before I knew what soil was, knew how to spell it, or could tell you how soil was any different than dirt. But today, I'm hoping to share that distinction with you, and I'm going to give you 3 tools for spreading that information with your friends. You're going to be really cool. This is why I'm here today. This is a boat that was washed up in Hurricane Sandy. Global change is becoming more of a reality for us. It's hitting closer to home. And the thing is, global change isn't just climate change. It's not just food insecurity. It's not just political uprising. It's really quite complex. And one of the challenges is that currently the way we look at our resources, the way we look at air, water, and food is by envisioning them as separate. And Aldo Leopold suggests that perhaps we abuse the land because we see it as a commodity belonging to us. And he tells us that only when we see the land as a community to which we belong will we begin to love and care for the earth. Now, when we're looking at all of these resources as separate, that's really hard, right? How is the impending Baconopolis related to Hurricane Sandy, related to, I don't know, this thing called peak phosphorus? Drawing these connections can be really difficult, but it's the starting point. And there's something really interesting going on here, though. There is one substance, one material that can connect all of these things. And that one substance is soil. This person is here today. So I'll never forget my first introduction to soil class. I was sitting front and center, like a good undergrad, and the professor, Dr. Maya Kurzik, steps up to the lectern, and she tells us, "You are here to study soil, not dirt. Dirt is what you scrape off of the bottom of your shoe. Soil is priceless." There was a rumor that if you used the word dirt in her classroom, you would get kicked out. But none of us was ever brave enough to try that. So I learned a whole lot more about soil than just, it's not dirt. I learned why. Soil's really cool. And so coming up with a basic definition of soil, well, it's the stuff that covers the surface of our earth, and it's got minerals and organics, it's got living and dead things in it, and it's generally capable of supporting plant life. You can see plant roots in this photograph. They're the fine squiggly wires. But you can see a whole lot more going on here. And there's actually a definition that I prefer. Carol Williams, she has a little poem about soil. She tells us that, most of all, one discovers that soil does not stay the same, but is always changing and telling its own story. Soil is the substance of transformation. And if there's one thing we need right now on a global scale, it's a transformation. So you can see transformations happening right before your eyes. You see that red color that looks like rust? That's iron. And that tells me that where there's that red color, there's air in the soil, right? Because iron rusts when there's air present. Where there's not red, it's wet. It tells me that there's not much air there. That's pretty neat. Soils do more than just convert iron to rust and back and forth, though. Soils are actually able to help sequester carbon from the atmosphere. That's a pretty big deal right now. As plants grow and their roots grow into the soil and decay year after year, they build that up. Soil can do more than that, though. Soil can exist as a healthy part of an agroecosystem, but poorly managed soils can lead to eutrophication, like we're seeing here, all that green slime. I don't think the ducks like it very much. We just heard about the potential for a pipeline and oil. Well, soil has all sorts of microorganisms in it. It's host to biodiversity that we haven't actually explored yet. Hundreds of thousands of microbes that we haven't identified as species. But we know that some of them have the unique ability to break down hydrocarbons. Soil, when poorly managed, is not of much use to us at all. Soil affected by salt and drought cracks so that no plants can live in it. So it's our responsibility to care for it. Soil, when poorly managed, is not only useless to us, but it can cause environmental damage. This is a photo of the Connecticut River. Soil that hasn't been protected from rainfall is washing out into tributaries and is washing out through the river into the ocean, where it could cause harm to aquatic ecosystems. Soil is also, despite all its wonderful qualities, at risk when there's construction going on. Even here in British Columbia, in the Lower Mainland, construction is a big challenge because everyone wants to live here. It's a beautiful place. But managing that development with the need to protect our soil resources. Because once soil is removed from an area, that land is never the same. For our human purposes, soil is non-renewable. And what I mean by that is it takes thousands of years to form. Our soils here are pretty young. They're only 10,000 years old, you know. So there's yet another challenge with all of this. Soil science isn't hip. This is Andrew Jacoy. He's one of my mentors. He is a retired forester and soil lover. And here he is volunteering his time. He's teaching a group of soil science students about forest soils. Maybe he's showing that all of these trees are connected beneath the ground through fungal networks. It's kind of like Avatar. Yeah, but the challenge is that folks like Andy and other soil lovers are retiring, and yet over the past 30 years, there's been steadily declining student enrollment in soils. And this is unfortunate because education around soil is maybe one of the ways that we can address global change. Global change is a very complex thing, and Wendell Berry has a lovely quote that I'd like to share with you. Wendell Berry talks about education, and he tells us that the complexity of our present troubles suggests now, as never before, that we need to change our present concept of education. Education is not properly an industry, and its proper use is not for industry, either by job training or industry-subsidized research. Its proper use is to enable citizens to live lives that are economically, politically, socially, and culturally responsible. And now this cannot be done by accessing what we call information, and that is to say, facts without context and without priority. And perhaps it's this mismanagement of facts that's led us to where we are. Now, what if there was a way to deal with not only the shortage of soil scientists, but also to address in education the complexity of solving big problems? That would be pretty cool. And that's what was going through the heads of Professors Kurzik and Bomke about 10 years ago, or 10 years ago now. They created this course. They called it Sustainable Soil Management. I signed up for it. I thought the title was pretty cool. And like any good undergrad, that's about all I read about the course. So I walked in expecting to be lectured at, expecting to complete assignments, write a test, get a grade that would show I had learned something, hopefully. But what I was met with was something entirely different. Instead, I got to choose real-world problems that I wanted to work on. But I didn't get to do it individually. I worked with groups of my peers who were also interested in those same issues, looking at the UBC farm, looking at local forests, the landfill. And something about that course stayed with me. After I graduated, I went on to intern on farms, do some agriculture research. I kept finding myself coming back to this course. And so finally, I decided to come back to UBC and do a master's in soil science. And not just to study soil, but how we can teach people about it, how we can spread the message that soil is not dirt. And so there are 3 things I learned from this case study that I did of this class. I learned that context is vitally important to teaching people about how we manage our land. And this really came up in an interview with an engineering student who was taking the class. And I asked her, what do you find challenging? And she responded, well, the chemistry. As engineers, we don't always look at chemistry. And the interesting thing was that the case she was working on was looking at an irrigation system that had been installed in Rajasthan, India, by a group of Canadian engineers who had failed to consult with a soil scientist. And as a result, this irrigation system actually caused widespread salinity. That's salty soil that nothing can grow in. So this really drove home the point to her that even as an engineer, it's important to look at all elements of this system. Now, connection, the second take-home point. Students not only connected to the material they were learning, the soil, getting up close and personal with it, but they got to connect and interact with each other. And that really was exemplified in one case where I was working at the back of the room with a well-behaved, quiet group. Up at the front of the room was a group of forestry students, and they were studying forest biology and how when logging occurs, forest productivity can sometimes go down because the microbes that live in the soil and the insects are affected by all that logging traffic. And as foresters who want BC's soils and BC's forests to be productive, each person was strongly invested in this. And so what wound up happening was about half of the group members were standing up at the board, writing and scribbling away and talking. But they weren't talking to each other. They were talking at each other. And as a result, the noise, the sound escalated and escalated as each of them tried to be heard but couldn't be heard because everyone else was talking until no one in the class could hear themselves speak, let alone think. And finally, one of the group members stands up and she says, "Stop. We have to work together." Now that was a transformative moment for her, as a quiet student, hardworking, but not necessarily a leader in group situations. It was transformative for her group members who thought that they were leaders and who wanted to take on this role, and realizing that in order to solve these kinds of big problems, people have to work together and communicate their unique knowledge, not just tell people what to do, but also listen. That transformation kind of spread out like a ripple effect to the entire class. And by now you've probably seen that there is challenge involved in this course. The role of challenge really was introduced by the instructors who provided the students with the necessary structure and resources to get started, but always encouraged them to go one step further. And this was exemplified by a group working on a brand new case, looking at starting a community garden at a local elementary school so that these students could see where their food came from, just like I did when I was a kid. And this group got so involved in it by getting involved with the students and the instructors that they created a poster. And this poster actually won an award at a regional soil science conference. By no means a class requirement, but they did it anyways. So this combination of context, connection, and challenge is what drives home the ability to manage land sustainably by working with others. As much as I would like to think that every student from this class is going to go out and be a soil scientist, I can accept that they're not. But the interesting thing is that I know that they all have this foundation. For example, one student, he's going to be a chef. And I know that when he's working in the kitchen, he's going to want to know that the vegetables he's cooking came from soil that was well managed. And I know that he has the capacity to work with his teammates in the kitchen to make that happen. Now, what about the rest of us? We're not all students, and even if we are students, I bet your course schedule is pretty full. The thing is, context, connection, and challenge as a means of addressing not only issues around soil science, but global change. We've already started. We've got context, we've got global change, we've got a baconopolis, potentially. Where's the connection? I think that's really important because when it comes to learning about the environment, Aldo Leopold warns us that one of the perils of an ecological education is that one lives alone in a world of wounds. But it doesn't have to be this way. There's 7 billion people on the planet. And you know what? Each and every person in this room wants to be able to drink clean water, breathe clean air, have access to healthy, affordable food. And each and every person in this room has something unique to offer to the conversation. We're all teachers and we're all learners. So my challenge to you today is that the next time you hear someone use the word dirt, you start a conversation about soil. And you might just change the world. Thank you.